GitHub. So coming to the challenge, okay. Uh, it's a Kubernetes challenge. So what was the error? I mean, issue you faced, Mahesh?
Yeah, I'll share my screen.
Okay.
Are you able to see my screen?
Yes.
Yeah. You know what I did actually? I have created a three server in my local. One is the master, and one another is the node 1 and node 2.
Hmm.
So for that, I have installed the Docker for three server as well, and I installed the kubectl, uh, kubeadmin, and shit,
And it's works, right? I mean, the Kubernetes.
sorry, your voice is breaking, Tawfiq.
Give me a second. Now it's clear, right?
Yes. So we installed the kubectl and kubeadmin for all the three server. So when I try to do the kubeadmin, let me add so
Yeah, continue.
m. Hey, I'm getting this error. It is saying that crctl is not found. I'm getting this error.
Hmm. Okay.
You can see Kubernetes version is v1.30.3.
Hmm.
So I'm stuck here actually. I'm not moving further.
Uh, Show me the GitHub code I shared with you.
Did you run the system control enable kubelet dot service?
Yes, yes,
You ran that already?
yes.
Not this one actually. Now we are facing error with the creation of Kubernetes, right?
Yes.
So first we need to sort out that issue.
Okay. Okay. Okay, then I'll stop sharing my screen.
Mhm. Mm, Better, I think I will share the codes. I believe that you have the codes, right? To configure the self-hosted Kubernetes. I already shared.
No. Do you have Amol?
Yes.
Amol,
What
do you have the configuration code to set up the Kubernetes?
configuration code is in the WhatsApp, right? I think.
It is.
Yes.
Do you need
A
me to
text
send that?
file. A text file that's containing the entire code to configure Kubernetes.
Okay, let me send that to you. So please read and design. I think you had the please read and design page there, right? Already the PDF.
Yes, yes,
Well, there's a configuration code in on the GitHub somewhere. In
yes.
admin somewhere. Okay.
My screen is visible, right?
Yes.
Okay, coming to the lab. Okay, coming to lab, we have several different types of challenges inside the lab. First challenge that we need to sort out, there is a broken Docker file.
Okay.
So first we need to sort out this issue. Then need to build the Docker file. Okay, build Docker file
I think your screen is not being shared.
locally. Uh, Mahesh, you can see my screen, right?
Yes, I can see.
Mm, my whiteboard, right?
Yes.
I'm on.
Yeah, I can see it. I think there are more tabs in my Zoom now. It's updated.
So this should be run inside local machine. For example, we have a local machine, sorry, a EC2 machine. So install the Docker, then copy the Docker file there and do the adjustment. Then we can run the Docker file. I mean, we can build the Docker file. Okay. After that, we will get the image, right? We will get the image, Docker image. Then we need to push to Docker Hub. First part is done using the broken Docker file. Then we need to uh, fix the issue. Then we will build the Docker file in our local machine or the EC2 machine. After that, we will push the image, tagging and pushing to Docker Hub. Then coming to Kubernetes part, Kubernetes will create Kubernetes, configure Kubernetes. Okay. In your case, you deployed self-hosted, right? Self-hosted, or we can go with the
AWS
EKS.
manage.
Then we need to create YAML files. Okay. In our case, there are different application there, A, B, and C, right? The requirement is, I will show the requirement. We have three application. We need to create three applications. A, B, and C. Okay. So the A application, we will create one pod. Inside the pod, the A container, the application A running. This is our B application. There is a container and there is a pod. Okay. And C. Application container. Container and pod. So the requirement is the app A communicate with B and C. Same way, B can communicate with A and C. But the C only communicate with B, not A. This is the requirement, right? So to fulfill similar type of requirement, okay, in Kubernetes, we use one service that is called Kubernetes Network Policies. This is nothing. This is actually create a internal network for network rules and policies within the Kubernetes cluster. So by default, there is no default network policy in self-hosted or EKS. So we need to install one agent, okay, for the same. There are different type of agents like Planel, Cilium. Common one is Calico. I think you have heard about Calico, right? These are the common agents, okay? As per the requirement, we can install anything. So whenever we install any of this Kubernetes network policy agent inside our Kubernetes cluster, we can say there is a network policy we already installed. Then we can create a network policy YAML file. Network policy YAML file based on our application. That is, inside the YAML file, we need to create three YAML file for three applications. Okay, one network policy for this application, one network for this one, and another for this one. So inside the YAML file, we will include all the things like the traffics. Okay, for example, I am going to create a network policy YAML file for this application. So inside the YAML file, there is an option like incoming traffic and outgoing traffic. Okay, to this application. That is ingress and egress. These are the two words that we use in Kubernetes. This is actually incoming and this is outgoing traffic. Okay. So we didn't use incoming and outgoing in Kubernetes. We use the word ingress and egress. So when like the file network policy file for the application A, we will choose the incoming traffic to access this application. Okay, there is a syntax there. So coming to the ingress syntax, we can select the port selector, which ports can access or which ports can the traffic comes from the port we can allow. Okay, like that. So under the ingress, there is a port selector. So the port selector we choose app to B and B app to C. So the traffic coming from B and C will access or will communicate with the A. So that's a thing that we include in the network policy YAML for the application A. Same thing for B because B also connected with the A and C. Coming to C, we will only allow the port, ingress port for B. So no connection from A. Got it? Any doubt? Both of you?
So you have a Kubernetes network policy YAML
Mm.
file that
Mm.
defines A and B can talk to each other. A can talk to C, but C doesn't talk to A, and B and C can talk to each other. What is the syntax of this YAML file? Like, how does it look?
Mm. I will show you. I'll check. My screen is visible, right?
Yes.
Yes.
So
Oh,
this is
ingress
actually,
from pod selector, match
yes.
labels. Okay.
So coming to see, this is a different policy for different application. Okay. So this is the ports, policy file for app A. So here we can see the kind is network policy. Then the name for the policy like allow app A to B and C. Then under spec port selector, here we can see the port selector, the application A. Then coming to policy, here you can see the ingress and coming to the ingress. I mean, what are the incoming traffic hitting to this application A? Okay. So that we define under the ingress from port selector and match label. So from the port B. So the B can access the application A. So this is the policy for application A. And we add one more port here, C. Same way, port application B and application C can access this this A, right? So similar way, we will create three network policy for each application. So this is B. Similar way we access using app A can and app C. Give me a second. And coming to app B, app C. Coming here, we only added only one port selector for app C. That is B. So the A couldn't access app C. Got it. So this way we uh, create the policy within Kubernetes cluster, but ensure that only this affect after we installing the agent, like installing the network service, Calico, Flannel or anything. Otherwise, this won't work. Fine. Both of you.
Yeah, the syntax will take some memorization to remember like that, but
It's simple. Like, for example, if you add more port, then we need to add the ports. I mean, adding in the under the ingress the port name. I
okay.
mean, in real scenario, I will coming to real scenario. We have one application. Okay, this is a front end application, and this is the back end. Both are running in different ports. Okay,
Mm.
so we have a database. So it's running an application. So all the, for example, for the front end, this is the front end, and this is a back end application. Okay, so the requirement is only the front end application access the database. This won't access there is no connection between uh, uh, other pods that running in the Kubernetes. So similar scenarios we can choose network policy. So coming to uh, database network policy, we will add only the connection from the front-end application or any required port selector. Got it?
So it compartmentalizes and controls the flow of communication or
Traffic.
security, basically. So how is this? This seems very similar to the whole concept of gateway, and then only the
Yes,
gateway can
yes,
access
yes,
the
yes, yes.
right.
Actually, this is we will create a network connectivity inside a Kubernetes cluster. What are the traffic comes, what should goes
Your
like
voice
that.
is breaking up, sir.
Now it's clear, right?
Yeah, yeah.
Yes, it's similar. Like we will create a network, entire network thing within a Kubernetes cluster and routing the traffic between different ports as per the requirement. By default, coming to Kubernetes, okay, we deploy some port an application, okay. So that application runs within the ports. So each by default, each ports can access other ports in the Kubernetes cluster. So using network policy, we will make sure which pod accessing other pod or similar like that. As per the requirement, we can choosing the ingress and egress within the policy file. So I am going to create a Kubernetes cluster. Okay, create.
Looks like Mahesh got disconnected by accident.
Mhm.
You might have to let him back in as a host.
Sure, sure. I think not here. So today we will focus on application tiers. Okay, there are different tiers when coming to application. Tier 1, Tier 2, Tier 3. As per the requirement, we will add the how many tiers that we need to include in our application.
Is these tiers similar to like front end, back end database, or that's something
Right, right,
different
right,
concept of tiers?
right, 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 right. Yes, he is back. Hi, Mahesh.
Hi, I can hear now.
Okay, okay. So today our topic is discussing on tiers. Okay, there are different tiers of applications or small services that we are going to create.
Are we going to discuss a new topic, or are we going to work on the challenge which you are given?
I prepared the topic. This one, like for the challenge, I think we can discuss with the other members so that we can finalize. That would be better, right? Okay. So meanwhile, this will create. I will explain. My screen is visible, right? So today we will cover application tires. So coming to application, there are different tires, okay, as per the requirement. So when we building an application, at that time we planned how many tires for this application. For example, one tire, two tire, three, four, like that. As per the requirement, we can include 10, 20, 50, 100, that much of tire for our application, okay. So what are the tires? Any idea, both of you?
So the tiers are like different, like one tier could be a database, one tier could be a front end, one tier could be a back end. And then the application is built in these different layers so that each tier does a specific task, right? And then it organizes the software by compartmentalizing it. You could change the front end, but still the back end is the same. Or you could change the back end, the front is the same. It gives the flexibility to develop the product as you need it, or over time, whatever demands people put on it.
Right. Before that, I will explain one traditional way of application development. Okay, so in traditionally or some coming to traditional architecture. Okay, that is monolith. What is monolith? Monolith architecture.
So they used to believe that we'll build one very powerful computer. And then the people that developed Unix came up with this idea that lots of little pieces that work together are more powerful than a monolith. So they came up with this concept of having programs that are easy to work with each other and can combine, and everybody can focus on doing one thing really well. Each program can do one thing really well. And all those programs combine and become a very flexible, versatile software that can adapt. So it has gone against the monolithic. People are encouraged to restructure their code so that it is not monolithic.
Right. So coming to monolith architecture, application designed as single or indivisible unit. Okay, indivisible unit. So all the components, okay, like uh, the user interface or the business logics or the data or the data access are tightly coupled and run as a single unit. For example, coming to monolith, okay, monolith, similar like this. So this is the UI and this is the business logic database, any other services like that integrated to the specific application. For example, this if this application is a e-commerce application, the cards. Coming to monolith, the basic thing is all the service, okay, all the services are coupled, okay. And the next thing is for building the entire application, we should use only one language. For example, if we choose Python, then we need to use all the services or we need to build all the services using Python. Java, then all services should be Java.
This You have the 3, 4 circles. It says user interface, database, and what is the
Yes,
left one?
different services. For example, when we opening a e-commerce application, Amazon, okay. So the first page, that the landing page is, we can see the like the materials that they offer, right? For example, the products they listed. So whenever we choosing a product to a cart, okay, so the cart is running another service, right? You got a scenario, right?
Yeah. I'm just trying to read the letter you have here on the next to the left of UI. You have BU something LYM.
Which
Uh,
one?
so if you go 1, 2, 3, 4, then it's UI, and the left of UI there is a circle. There is a big circle with 3, 4 circles inside it. One looks like
Yes,
database UI.
that I mean it's a single application. Like
So you get the flexibility of like using a different language at each piece, right? If Java is good something for
yes,
a
yes,
front end, you can use the Java. If you like Python in the back end, you can put Python there, and you can
right, right,
leverage the strengths of all the different developers in the different areas. The system architecture.
right, right. So for example, this is the application, our main application, okay. So all application, okay, all the services that belongs to the application is coupled. This is DB, database. This is front end. And this is some, for example, this is a cart. We are taking an example of e-commerce, okay. So this should be the payment gateway or payment service. Some mailing service there. Because whenever the payment is done, we will get a mail, right? So each services within the application runs as a single unit. So, and here we use only a single language as well. All the services, this is one service, this is another one service, because this service is developed by some other developers, okay. There are a couple of developers there. So they will I mean, schedule some modules. So like uh, two developers will work on the payment side and one for the mail, like that. So after that, they will couple all the things and run. So this is the monolith way. So the problem here is, for example, if a issue with or some like adding some feature or anything with any side, okay. For example, uh, the front end page, we need to add some features there. So that there we need to face some problem, because here all the services are coupled, right? So after the changing to the front end application, we need to run entire application instead of a single piece. So it will take some issue if any issues there. Okay, for example, some the payment gateways have some issues. So if we need to stop the entire application to sort out the issue and fix. So here there is so many limitations and so many issues with the monolith. So most probably this is our traditional way of application architecture. Now the new trend is microservices, right? That's why we are using Docker, Kubernetes, all the things for deploying these type of microservices, right? Microservices. Coming to microservices, coming to microservices, uh, it's a similar application. Okay, we can take an example of a e-commerce application, e-com. So this is the front end. This is a database. This is a cart. And this is some other services that related to the full application. So now you can see the couple in previous monolith, all services are coupled, right? So coming to microservice architecture breaks down an application into small or loosely coupled independently deployable services. So this is one independent deployment service, and this is also one deployment service. This is also, and how many applications or how many services that we need to include in our applications, and we can add that thing like mailing, data access, or business logic, or any services. Okay. So each services focus on a specific business function and communicate with other services through well-defined APIs. So how these applications work, I mean, communicate using API. There's an internal API for accessing, for example, some users accessing the front-end application, okay, users, and they buy something or they are adding some products to cart. So from this service to cart, they send some communication using API. So coming to the cart, the users can see the products they adding to the carts. So here coming to the language use, okay, language, we can use different language. For example, this should be Python or this Java. Each services we can use different language. This is Node.js. And in previous year, we talk about the issues we facing or updating some features to the specific service. In this case, for example, we need to update something in the cart part. Okay, so only the developers taking the cart service and adding something there, then push to or updating the cart service. That is not depend to or any issue faced for another services running. Got it. Then coming to the advantages, we can say the microservice advantages, scalability, flexibility, resilience, faster development, and all the things there. Like in this case, individual service can be scaled independently based on the demands. For example, this is a service. Okay, so as per the demand, we can scale up this services requirement, all the things. So how we deploying this microservice application using Docker or Kubernetes. So for example, Netflix. So that Netflix application have n numbers of services, n numbers, around 800 service or 800 ports are running. Uh, I mean, for the Netflix application, and that is purely run in a Kubernetes cluster. And the monolith, still we use monolith. Okay, so the requirement is some small application or small team, then they can use monolith way. So coming to microservices, the application suitable for large applications like needed scalability, flexibility, and resilience. Got it. My cluster is ready. Any doubt? Mol Mahesh.
No, I think you explained the concept, but we've not actually built that right yet. Now you're going to build like, are you going to make one virtual computer for each thing, or is it lots of programs running on the same computer? I guess it doesn't matter because that's the whole concept of the cloud, and as long as they know that they're supposed to talk to each other.
Yes. For example, in this scenario, okay. In this scenario, we have 10, for example, we have to create 10 microservices. 10, 10 services. These services, in this lab, I will show you how to deploy 10 services or 10 tier application in EKS. So for 10 tier or 10 services, we need to create 10 Docker service, Docker file, right? For each application, for example, we have a front end app, front end service. For the front end, there is some codes, right? Some codes, and inside the code, we need to create a Docker file. So the Docker file wrap up all the things like creating a image for us. That image include the codes for front end application. Then we need to create a YAML file. Inside the YAML file, we use a similar image for the service front end. So similar way for the database, we need to create specific Docker file. For the cart, again, we need to create because each services have their own code with the language, and we need to create the Docker file as well for the specific services. Then we use the same image, corresponding image for the deployment using Kubernetes YAML file. For example, if we have 10 YAML file for this entire application, inside the YAML file, we choose the corresponding image. Got it?
Could you repeat this last point? Instead of the YAML file, use the image. Doesn't the YAML file define what the image will be like?
Image, I mean, coming to YAML file, we need to specify like which deployment is deployment, the kind. Okay, YAML kind is equal to deployment or service or anything that we can define. So this application all coming to the deployment. Okay, then under the deployment we need to specify the image, right? Which image that we need to run to create the pod and container. YAML image, the image that you forgot the image, right? Or confused.
No, you followed the image, you formed the image, right?
Docker image.
Yeah. You can make as many images of that one container that you want.
Each image contain each services, right? I mean,
No. I will explain. For example, our requirement is to deploy.
multiple services, right?
Yes, 10 services
Okay. So if you
in
want
each
to,
case. So 10 services in the sense of different pages. Okay. The first page is front end or the landing page. It will shows the goods and all the things there. Then the database. This is second one. This is one. And third one is like cart. Okay. So the front end service, we have a code, right? We have code. Along with in this case, we need to create a Docker file for the same.
I think, are you
For
sharing a
example,
different screen?
oh, sorry.
Yeah, now we can see.
So 10
So we are going to
application
deploy
requirement.
the 10 services we are going to, 10 tier we are going to deploy, right?
Yes.
Okay.
So 10 services
Kubernetes.
should be deployed in EKS, Kubernetes.
Okay.
So that we need to create, uh, we have the codes
Image.
for the
We'll be
application.
creating
Okay.
a image for 10 services. That will be 10 images.
Yes. Because that specific services having different codes, right? For example, the first two services one
Correct.
have Python. Okay. Just assume that second services have Java. And the codes in the repository, okay, the codes are there. Along with the codes, we need to create a Docker file. So we need to build the Docker file, build. So the
Okay.
build image we use for deploying Kubernetes. We have a Kubernetes YAML file. So inside the YAML file, we use the Docker image for the front end. I mean, the first service. Similar way, for the second service, we have another image. We use the image for deploying Kubernetes. Now Amal got the idea, right?
Yeah, let me just look at this page again. Python, code, Docker file. What is
This
this?
is just an
BUT?
assumption, okay? There are different scenarios there.
But I'm looking at what's the right of Docker file to it? BUT backend.
That is a build actually.
Build.
This
So
one.
in a user interface application, we have a couple of services like cart, like a search button, or different services will be there. Each services will have a different programming language like Node.js, Python, Java. So we can deploy each services in a. We can create a Docker image for each services, and we can
Hmm.
deploy through Kubernetes.
Yeah. Now you can see my screen, right? I will show you.
Better you open one user interface and show us. We can understand better.
Yeah, now my GitHub page is visible, right?
Yes. Can you go to Netflix page and show us? Like, Netflix or something?
Sorry.
Any? Hello.
Uh-huh. Yeah, I'm audible, right?
Yeah,
Yes.
we can hear you. I think Taufik was doing what Mahesh was saying, but he just didn't say anything. He was scrolling
Okay.
to.
Okay. So this is my application, okay? The application that we going to deploy. So coming to here, you can see
No, Tawfiq,
this.
before deploying, if you have any application like anything, Netflix or something, or the application which you are going to deploy now, open it in UI and show us that how many services are there in the UI page, not the backend, the front end application.
That I will explain.
Okay.
Before
Okay.
that, I will show you the codes and the Docker files.
Okay.
See, these are the services for this application. Okay, this tender application. This is a simple e-commerce application. This is developed by Google. So I forked that from the Google. So coming to here, you can see one service, ad service, cart service, next one, checkout service, currency service, email service. This is a front end, load generator, payment, product catalog service, recommendation service, shipping service. These are the service included in the application. So these services are different types. Okay. So coming to front end. So these are the codes that related to the front end application. Okay. And you can see here one Docker file. See, so this is a Docker file for the front end application. Got it. This is taking the Golang from official,
Yeah.
I mean, from the Docker Hub, then copying all the things using copy command, using work directory. Then finally, it will, we will run
Tawfiq,
the, yeah.
is it possible to show us how to create a Docker file? Because usually in the real time, we are not going to work on the source code file, which you're going to provide by the developer. So mainly we have to work on the Docker file, right? That is a config file
Mm,
to create a
I
image,
think,
Docker image.
yes, there is a section there, I mean, creation of Docker. I think you missed the class, right? Amol?
It's just like a YAML file where you specify how the thing will be built. Like, remember in the old days when you bought a computer, you installed one software at a time, and now the whole image on your hard disk was built, right? The Docker file just has like it's a YAML file that has a sequence of things that you will probably not build any image from scratch, but you'll probably install Node.js some version. So you'll have some command for installing Node.js, some command for installing some other software, and then finally, like this is like your image, just like it used to be on your actual physical hard disk machine. Instead, now this is just the image of a virtual machine. That's
Correct.
how the
See, if you want to create a Docker image, we need a Docker file, correct?
yes. Then you
Yes.
Docker run and give it
From
a
scratch. From scratch, we need a Docker file.
Yes.
Using the Docker file, we build a Docker image.
Okay.
And we need to keep the application, all the applications there. For example, you can see this is a service or this is an application for card service. So the all the codes are here, okay? The JSON code, startup script there. Then along with this, we create a Docker file to build all the codes. We will create a image. So this is a specific image for specific Docker file for building the card service. So we will get a image. Got it. So that image we use for deploying to specific uh, platform like Docker or Kubernetes. So in this case, we have 10 application or 10 different type of services, and each services have their own codes and their own Docker file. And I will show you the entire YAML file. See, this is the Kubernetes YAML file. See, this is for email service YAML. I think this is a huge YAML file for the entire 10 service application. See, we can run it as like keeping 10 files, or else we can include all the files within a single file. So here you can see different kinds, that deployments, then the name, then the services, and the integration with the different port.
Tawfiq, do we need to create a different Docker file? I mean, Kubernetes config file for the different service?
Yes, this is similar like that. You mean, for example, we have 10 YAML file, right?
No,
Creating
we have
10
10
YAML.
services, 10 tier actually.
Yes,
We have
yes,
10
yes,
different services.
yes.
So what I did, hold on one sec. What I did actually, I have created a YAML file for one YAML file for all the services I deployed. So
Hmm.
in between, there are two services which need to upgrade, and again, I want to deploy that one. So I have to create.
Yeah, that coming to Kubernetes, for example, if we deploy using this file, okay, so the Kubernetes know the configuration of the existing file. For example, I need to just modify one of the file, okay, like the add service. So this is for add service, okay. So what I am coming to here, I will change the port selector or replica. So any changes that I made here, then after I reapply the entire image, only Kubernetes will take the new changes.
Oh,
Got it?
Okay.
Yeah.
It's not going to affect the different layers,
No,
right?
no, no,
The
no, no,
other
no,
service.
no.
Okay. Then it's better to keep all the YAML different services in one YAML file.
Yeah, both are same actually, but this is more time consuming. Like, I
And it
mean,
will apply
this
to
is yes,
wherever the line we want, you can go and modify and save it and you can deploy it.
right. Or see, you can see here there is different YAML for each services. For the and service, this is a YAML, simple YAML. So
Okay.
in that case, we include all the files in a single file. That's we can easily deploy. So I'm going to copy the enter command. See, my file is here. So I'm just applying using kubectl. Oops, apply the file name. Okay, .yaml. I believe this will create 10 different ports with the container. Sorry, some one P added. Apply. See, container creation. It will take some time. Only two for the service add and cart. The container is still waiting. Yes, now one is cleared. Mm. See, everything is up and ready. So each services is ready, and you can see we will get the external URL, the DNS, to accessing our application. So just to copy. Yes, it's visible. So it's a online boutique. See, whenever we clicking different page, okay, each are different services. I'm going to add card. So this is another services that is name is card service. So each service is in different tiers actually. You can place order, continue shopping, add to cart, go back. See, we can see the things that we added in the cart. Because this application have one database that is Redis database. See the Redis. So everything is fine. I will show the architecture, okay, for this application. See, this is the architecture. So user hitting the front end, I mean the where the landing page, then the load generator there, checkout. Coming to checkout, we go to the payment and email. So it will generate a email. Then the ad
Is load
recommendation.
generator for testing?
Yes, yes. Then we have shipping, currency, cart, Redis cache. This is a small size database for caching all the things. Here you can see uh, I'm choosing ad. So this is caching our cart data. And see, now it's two. Continue shopping. And now it's three. And we can see the data that we cached in the database here. Got it.
Yes.
Here also it will calculate all the currency. Any doubt? Both of you?
No, it looks okay. There are all these little. It's just like the Unix ecosystem. Like each program does one thing and works well with other programs.
Yes.
They used to call it the fellowship of programming in the 70s or 80s.
Right, right. Mahesh, you have any doubt?
No, as of now, Taufik. I have to work on this one.
I think you have a running but you missed that thing, right?
Yes.
I will share the code. So you can use this one, okay? This is a simple one. Just to copy and paste it on master node and worker node. After that, this runs only on the master node. So after that, you will get a kube joiner command when we are running this init and all the things. So paste that and copy that and run it on slave, so the worker node. So the worker node will join to the master. I'm pasting here. You can copy. Did you get
Yeah.
the link?
Yeah, I got the.
Yeah. This will work, okay?
Okay.
This is actually a script actually. Otherwise, we need to run this one, then second this one, like that.
I'll go through that one.
Okay. Then we can wind up, right?
Sure,
Yes.
sure.
Okay. Then bye.
Okay.
Bye.
Thank you.
Thanks. Have a
Good
good
morning.
night.
Good night.
Good
Good night.
morning to you, Taufik sir. Bye.
Yeah.
So are we having lesson tomorrow?
Yes. We
Is
have
it the-
one lab. I think I didn't use Argo CD, right? Only we used Jenkins for CI and CD. But one more term, like one more service is called Argo CD there. So in our pipeline, we only using Jenkins, right? So Argo CD is used for deployment, continuous deployment. It's a CD service. So tomorrow we will go through the Argo CD and set up in Argo CD, and using Argo CD, we will deploy application. It's a
Okay.
GitOps project, okay? Using GitHub and Argo CD, we will deploy our application.
Okay.
Yeah.
Thank you.
Yeah. Bye then.
Bye.